Welcome to module 4 of programming in C++. In this module, we are discussing sorting and searching. So, the objective is to look into the implementation and use of sorting and searching in C and contrast them with C++. These are the topics that we are going to discuss. So, to get started, all of you know sorting, and you must have written several programs in C to sort a set of integers given in an array. So, here we just show one of the most common sorting algorithm known as the bubble sort. You may or may not have used bubble sort. If you have done some other selection or insertion sort, it is perfectly fine. We are not going to get into the logic of how the sorting is done. All that I want to show is between the two columns, left is a C program, right is a C++ program. Both are trying to do bubble sort using exactly the same strategy, the same algorithm, and you can see that the only difference they have between them is the use of the IO header and the STD namespace. So far as the whole algorithm is concerned, the code is concerned, the arrays and comparisons are concerned, it is just identical. So, the first lesson that we take is any sorting code that is written in C can be identically used in C++. Now, I would like to illustrate that if I need to sort a set of numbers or a set of strings, do I really every time write a sorting program myself? I do that when I am trying to learn algorithms or when I am trying to learn the language, but subsequently if I want to sort a set of numbers, I would not like to write the algorithm myself, rather I will again go back to the standard library and try to use what standard library provides. Now, let us concentrate on the left column, which is a C program. It is using a sorting function provided in the C standard library in the header stdlib.h. This function is known as qsort. The name certainly refers to the fact that this function uses quicksort as the underlying sorting algorithm. Now, please concentrate on how the qsort function is called. You can see that there are 4 parameters. So, let us see what are the things that you need to tell the qsort program so that it can sort your data. Certainly, you need to tell where the data exists. So, that is the container, which is an array data here. So, that is the first parameter. Now, the array could have any number of items, any number of elements. How will qsort know how many elements does it have, or out of the containing elements, how many of them you want to get sorted? So, the second parameter tells qsort that how many of the array elements you want to get sorted. It means that you always start with index 0 and take as many elements as are specified in the second parameter. So, here the second parameter is 5, which means that qsort should sort data array from index 0 to index 4, which in this case happens to be the whole array. The third parameter is little tricky, and right now you may not understand why the third parameter is required. The third parameter says that please provide the size of every element in bytes. Now, this is an integer array, which means that every element is an int. So, the size of every element can be computed from using the size of operator in C. So, you specify size of int, which for a 32-bit system will pass 4, since int typically in 32-bit is represented by 4 bytes as the third parameter. It is difficult, maybe difficult for you to understand exactly what we need this, but the basic logic is that since qsort does not know what type of data your array contains, it could contain int type of elements, it could contain char type of elements, it could contain pointer type of elements, it could contain structure type of elements. It is not possible for QSORT to know after it has got the address of the 0th indexed element, where should it find the first indexed element. So, if it knows the size of the element, it will be able to add that as an offset to the starting address of the array to get the first element. Then it can again add that same size of int offset to the first element's position to get the address of the second element, and so on. So, that is the implementation for which you need this information. So, that is the third parameter. The fourth parameter is the most interesting. The fourth parameter is a function pointer. In module 1, you will remember we have talked about function pointers in depth. We have recapped that, and if you just move your attention to the top between the includes and main, you find that a function pointer compare has been defined, implemented for the purpose of use by QSORT. Now, what is the role of this compare function? This compare function will take two values, compare them and say whether which one, the first one is smaller or the second one is smaller. So, here we have shown a compare function where we are using less than as a comparison. So, if the first one is smaller than the second one, it will return a true, and otherwise it will return a false. This is the basic purpose of the compare function. Now, you will wonder, why do I need to do such a complicated thing as writing a separate function pointer function and passing that function pointer? You will please have to understand that when QSORT was written in the library, or if you want to write a QSORT kind of function now, and you are not told what kind of elements you will need to sort, how will you know how to compare those elements? For example, int can be compared very easily, but if I have, say, instead of int, if I now give you an array of strings. Now, the array of strings cannot be compared simply by writing a less than or greater than in C. We are not talking about C++ string right now, which you already know has a comparison operator. So, in C, if I have to compare strings, my values are actually pointed to character, but my comparison has to happen through the use of some strcmp function. Now, how would QSORT know? QSORT did not know what kind of data you will give QSORT to compare them. Therefore, QSORT also does not know how to compare two such data items, and it is your responsibility to provide that compare function to QSORT. So, you need to have this fourth parameter, which is the compare function pointer. If you look into the header, the signature of the compare function pointer, you see something which is even more disturbing. You can see that the parameters are declared as of const void star, that is their const pointers to constant data of unknown type. Why is it that? Because again QSORT could not have put a signature for the compare function pointer, because it does not know the type of data item. So, all that is assuming that you have a pointer to some type which is not known, and since you do not know that type, well, you actually want to do the comparison in the return statement of the compare function, you will have to first tell the compiler that what indeed I now have is an integer. So, you cast the void star pointer first to int pointer, then you dereference that int pointer to get the integer value, and then you compare the two integer values. So much need to happen for the QSORT to be used, and that is one of the reasons possibly that even though QSORT is available in the C standard library as a default sorting algorithm, the use of QSORT has not been that popular in the C community. Often people prefer to write their own functions, bubble sort, selection sort, or insertion sort, merge sort, whatever, given the data type of elements that they want to sort, and just use that. Let us now look at the right side of the column. the C++ way of doing it. I will not get into the differences in terms of IOs, you already know that. What you must focus in terms of the include is we include another C++ standard library header called algorithm, which is very, very interesting. Algorithm is a header which contains a whole lot of algorithm codes that you need to often use in your program. So, algorithm contains one of the components is the sort algorithm. So, what you call qsort in C, this component in algorithm is called sort. We are again sorting the same data, we are again sorting in the same order. The way what I need to specify for sort, let us look at the parameters, certainly the container, which is same as what I did in qsort. The second, I need to tell how many elements from the beginning. This we specify in a little bit different way. In qsort, we just specified the number of elements. Here we pass the pointer to the first element after the point of attention. So, we pass data plus 5, which means that we pass the pointer to the index 5 element, which is just beyond the part of the array that we want to sort, which in other words mean that you sort 5 elements starting from data. We will look at these details later on. This is called a range in C++. The third parameter as of qsort is not required, because as you have seen before also that C++ compiler can deduce things based on the type. So, type it knows that data is of int type array. So, the elements will be of int type. So, you do not need to separately specify the size of int as a parameter. The third parameter of sort is same as the fourth parameter of qsort, that you need to give the comparison algorithm. This certainly cannot be deduced, because depending on which type of data you are sorting, your comparison strategy would be different. But what is significant is if you again move your attention back to where this compare function is defined in the C++ part. Now, you do not have that complications that you had in C of using parameters which are of const void start type, or the expression which does a whole lot of casting and dereferencing. Now, you can declare the parameters exactly as you declare in case of a normal function int I, int j, and in the return you simply compare them, whatever that comparison logic is, you will just write that here. So, it is pretty much like a normal comparison function, and that function pointer, function name will be passed as a third parameter. You can do this in C++ because of several features that C++ introduces, which we will slowly introduce to you. So, you will understand why this was not possible in C, but it is possible in C++ to write the compare function with any type that the sort function did not know beforehand, but can still be able to absorb that. So, with this certainly it becomes a lot more elegant and efficient to use the sort program from the standard library, and the consequence therefore is that C++ programmers rarely write their own sorting program, they just make use of the sort as is given here. There are small nuances to note. The convention of the direction of sorting, whether it is decreasing order or increasing order, differs between the qsort implementation and the sort implementation. So, you will, if you again focus on the two compare functions that we have written, you will find that in C we have used a less than to be true, in C++ we have given greater than to be true, because in both cases we want the sorting to be done in descending order. So, this is just a matter of convention that exists in C++ sort. This is just another version of the sort. Here, if you look into the particularly the call of the sort function, you see that the first two parameters are there, but the third parameter is not there. That is, the compare function is not provided here. So, this is a shortcut that C++ standard library allows you. is if you are trying to sort arrays of type which is known to the C++, that is of the built in types, then it is optional to give the comparison function. The comparison function is not necessary to be provided, and if you do not provide that, then by default the sorting happens in the ascending order. So, if you still want to sort this array in descending order, you will again need to provide the compare function, because your direction of comparison, that is whether the first parameter being greater than the second is true or otherwise, will change between the ascending sorting and the descending sorting. Next we will move on to binary search. We all know that binary search is a very frequently used algorithm in programming, which given an array of elements which are already sorted, binary search can find out whether a given key exists in that array. If it does, then it can also say what is the position of that element in the array. This is of the simple searching mechanism, this is one of the most efficient one, and both C as well as C++ standard library have mechanisms to do binary search. In C, it again is available from stdlib.h. It is a function called bsearch. In C++, it is again available from component algorithm, and it is called binary underscore search. If we look into how this is used in C, on the left hand side, by bsearch, the first parameter is the key. The key has to be passed as its address. So, you pass ampersand key. There is a reason why you need to do this, because again you do not know the type of elements that you have in the array, and therefore, the type of the key that you want to search. So, you do not know the type of the variable key in general. So, you cannot write bsearch with that. So, you again make use of the fact that you can use a pointer to int and consider that to be a pointer to void. So, bsearch uses the first parameter, which is void star, and that is the reason you need to give it the address. The second parameter is the array in which you want to search. Certainly, this has to be sorted. The third parameter is the number of elements. This is pretty much like qsort. The fourth parameter is the size of every element, and the fifth parameter is the function pointer of the comparison function. Point to note is binary search has to make a three-way decision, unlike sorting, where you just need to know whether it is less or is not less. But binary search has to, when it is looking at a particular element in an array, it has to deal with three possibilities. One is the element that it is looking at may actually be equal to the key, that actually may be the key. So, then you are done with the search. So, you do not need to do anything, you just return that index value or the position of the array. Second, it could be less than that key. If you have your array sorted in increasing order and your value is less than the element that you are looking at, your key is less than the element that you are looking at, you know that you will have to look at the left part of the array. And in the third case, you will have to look at the right part of the array. So, your comparison function has to be a three-way function, pretty much like the strcmp function we have in the string.h standard library in C. So, on top here I show how you can write such a compare function for the case that we are dealing with, which returns -1 0 or +1 as the case may be, and all the nuances of using parameters as void star pointer and casting them, dereferencing them, as we did in the case of qsort, will also be involved in this case as well. Let us look at the C++ form for this. The binary underscore search function from algorithm component takes the first parameter as the container, which is the data. The second parameter is the end of the range. This is pretty much like sort, as we have seen, and it takes the third parameter, which is key. And here I am showing an example where the compare function is not explicitly provided, because as I have already discussed in case of sort, that if you are doing a search for elements of built-in type, the compiler already knows how the comparison is done. So, you do not need to explicitly put a function pointer for comparison, and with this the binary search will happen. If you compare these two, you will find the ease of using the binary search in C++ is immensely more compared to the ease of using it in C. And again, for that matter, binary search in C++ is very often used, and nobody will write a program for doing a binary search for any type of data container that someone has.